Hello students, yesterday we learnt about these retardation plates. Two types are there, quarter wave plate and a half wave plate. So now today we will be studying about this plane elliptically and a circularly polarized light by the analytical method or by the analytical treatment. Both are one and the same. So here the figure has been shown in the figure 1. This is figure 2. Let us consider now the plane polarized monochromatic beam of light is incidented on a uniaxial crystal. Now the crystal is there. To the crystal you incident the light. A plane polarized monochromatic light incident on that crystal like a calcite crystal. It cuts a normal with its face parallel to the optic axis as it is shown in this figure 1. We can see here in the figure 1. The ray after entering the crystal at the point P. Here the point P has been representing. On entering the crystal at a point P, the plane polarized light splits up into the two components. Already we have learned that when the light is incidented on the crystal, it is going to divide into the two parts. So here on entering the crystal at the point P, the plane polarized light will split up into the two components. One will be the ordinary wave and another one will be the extraordinary ray. Now here it is represented. This is an extraordinary E has been represented and this will be the ordinary. Okay. So ordinary wave vibrates perpendicular. Ordinary waves vibrates perpendicular to the optic axis. Ordinary wave is vibrating perpendicular to the optic axis. And the extraordinary ray is a parallel to the optic axis. Extraordinary ray is a parallel. It is a parallel to the optic axis. Ordinary ray is a perpendicular and extraordinary ray is a parallel to the optic axis. These two waves moves or travels along the same direction but with the different velocity. Look at this figure 2. So here we know that ordinary wave ray is a perpendicular to the optic axis, extraordinary is a parallel to the optic axis, and these two waves are traveling along the same direction but with the different velocity. We can look at here at this equation in the figure 2. Okay. These two waves are traveling along the same direction but with the different velocity. The E is the extraordinary, O is the ordinary. Here is the point P here. So when they travel through the certain distance of the crystal, let a delta be the phase difference between them. These two waves are traveling in the same direction but with the different velocity. When they travel through the certain distance of the crystal, let us consider now delta be the phase difference between them. Let A be the amplitude. Okay, the capital A be the amplitude of the incident vibration, which makes an angle of theta. Let capital A be the amplitude of the incident vibration and it makes an angle of theta. The plane of vibration is going to split up into the two individual vibrations of the amplitude. There is a small a and a small b. Small a and a small b, what it indicates that? It indicates the amplitude for the extraordinary as well as an amplitude for the ordinary rays respectively. So therefore I am representing for the extraordinary. The amplitude is A is equal to capital A cos into theta here. The capital A cos into theta. This is for the extraordinary. And the B small b is for the ordinary. There is A into sine theta. So these two waves, this ordinary as well as extraordinary waves are vibrating in the plane perpendicular to one another. They are vibrating because it is extraordinary is in a parallel, ordinary is in a perpendicular. So they are two waves are now vibrating in a plane perpendicular to each other, to one another. Suppose now if you consider capital X and the Y, this X and Y be the displacement of the particles. Okay, X and Y be the displacement of the particle to these two vibrations, then the equation can be represented. We can represent in the terms of an equation. We can write the displacement for this extraordinary as well as for the ordinary. So when now extraordinary, this x is equal to a cos theta sine omega t plus delta. Already we can represent, so when the waves is traveling, when the wave is in a traveling, its displacement, how will represent now displacement? X is equal to a sine into omega t plus theta. But here the a is an amplitude. Okay, for a extraordinary, we know the amplitude is this one, a cos theta. So we representing as an a cos theta sine omega t plus an delta. Similarly, write down the displacement for the ordinary ray. So y is equal to a sine theta sine omega t. This is the amplitude for the ordinary, and this one is a sine theta. This is a sine theta. Okay, sine omega t. So now we know that small a is nothing but capital A cos theta and small b is nothing but a sine theta. Already we have written here. This I have written again here. Okay. Substitute this in the place of a cos theta, you represent as a small a. In the place of a sine theta, you represent as a small b. So now the equation, this x value will becomes now, x is nothing but it is equal to a sine omega t plus delta. So this you consider as equation number 1. Similarly, substitute the value of the b here in this place. So this becomes now y is equal to b sine omega t. This is equation number 2. Again, the equation number 2 can also be represented as y by b is equal to sine omega t. Cross multiply it. Y by b is equal to sine omega t. So this I am representing again in terms of a cos theta. That's a cos omega t is equal to square root of 1 minus sine square omega t. So again now further, this is represented as square root of 1 minus sine square omega t is nothing but y by b. So this becomes now y square by b square. So from the equation number 1, where is the equation number 1? Here. The equation number 1, this we can represent x, cross multiply it, there is a x by a is equal to this one, sine a plus b. Substitute the formula, sine a cos b plus cos b, sine a cos b plus sine b cos a. Substitute here. So this becomes now sine omega t cos delta plus sine delta into cos omega t. So this can be further represented as this one. We know that again sine omega t here, the sine omega t is nothing but y by b. Substitute here. In place of sine omega t, substitute as a y by b. So this becomes a y by b cos delta plus sine delta. Again cos omega t is nothing but square root of 1 minus v square y square by b square. Substitute again this one here. So again now this is in this way, x by a is equal to this value. Okay. This bring in this direction. So this becomes now x by a minus y by b cos of delta is equal to sine delta square root of 1 minus y square by b square. So now next step we have to square this equation. This one. We have to square it. So squaring this equation, we can represent now x square by a square plus y square by b square cos square delta minus 2xy ab cos delta. It is nothing but sine square delta minus y square by b square sine square omega into t. Okay, squaring this equation. This is a previous equation. So you have to square it. This square will get cancelled. You multiply this inside, that sine delta minus y square sine delta by b square. So this becomes as already squaring. It becomes a sine square. Instead of sine delta, it becomes a sine square. Okay, they are representative. So now, so here this is y square by b square cos square delta. Here also y square by b square sine square delta. So bring it on one, this will becomes a sine square delta and a cos square delta, both becomes a 1. So this we can represent again here, x square by a square plus y square by b square minus 2xy ab cos delta is equal to sine square delta. So here this value, and in this what you are doing, y square by b square you are taking outside, so that it becomes now sine square plus cos square theta. So this becomes a 1. So therefore y square by b square, we are representing as a y square by b square, and as this equation has been represented in this here, and this we have represented again here in this one. So this we are representing as a equation number 3. So this equation number 3 is nothing but it's a general equation for the ellipse. So the exact nature of the motion of the particle is going to depends upon the value of this delta. Okay. So now, depending upon the different values of the delta, we are having the plane polarized light, elliptically polarized light, and circularly polarized light. So when you will get the plane polarized light, so this will all values, when you get the plane polarized light, elliptical polarized, circularly polarized, these all depends upon this angle. Okay, delta. So now there's a phase difference, a delta. So let us consider now, we will study the case 1. This is a plane polarized light. When the value of the delta is equal to 0, 2 pi, 4 pi, then what happens here now? When you substitute the value of the delta as a 0, 2 pi, 4 pi in this equation number 3. So then sine of delta will becomes a 0, cos delta will becomes a 1. So the equation number 3 will changes to now substitute the sine delta as a 0 and a cos delta as a 1 in this equation number 3. So this becomes now x square plus a square plus y square by b square minus 2xy ab is equal to 0, because this term has becomes in a 1 and this is in a 0. So written as a 0. So this is nothing but like an a minus b square. So x by a minus y by b whole square is equal to 0. Okay. Or else we can write this one as a y is equal to b by a into x. So this represents the straight line. This is going to represent the straight line with the positive slope, that is a b by a, as it is shown in this figure here, this one, and represented here. This is the straight line. This is the straight line with the slope, that is a b by a, with the slope b by a, as it is shown. So now this shows that the emergent light is in a plane polarized in a same plane as that of the incident light, Now in the plane polarized light, again the second case is there. If the delta value is a pi, 3 pi, 4 pi, so then cos of delta will becomes a minus 1, sine of delta will becomes a 0. So again substitute these cos value and a sine value in the equation number 3. After simplification, we can write now x by a plus y by b is equal to 0. So you have to do this previous, how we have calculated in the previously, the same method we have to follow here. Only substituting this cos delta has a minus 1, sin delta has a 0 in the equation number 3, and simplifying we get x by a plus y by b is equal to 0. Or else y is equal to minus b by a into x. This has become a negative, and this is a b by a into x is a positive. So this represents again here straight line. You get again the straight line but with the negative slope. So now the emergent light will be the plane polarized light with its plane, as it is shown in this one. Second case, I have representing this is a second case. Again b by a is there but with the negative slope. This one is for the positive slope. This is a negative slope. This is the first case and this is a second case about this plane polarized light. Okay. Now we will move for this second case, elliptically polarized light. Here when the delta value is a pi by 2, so sine delta will becomes a 1, cos delta will becomes a 0, and here a is not equivalent to b. The amplitude of the amplitude of the extraordinary as well as an amplitude of the ordinary, both are not equal. That is, a is not equivalent to b. Then we will get the elliptically polarized light here. So when you substitute this sine delta as a 1 and cos delta as a 0 again in the equation number 3 and do the simplification, you will get this value. X square by a square plus y square by b square is equal to 1. So this represents the ellipse here. We are representing this one as an ellipse here. This represents the ellipse whose major and minor axis coincide with the coordinate axis as it is shown in this figure. And the emergent light, the light which is emerging out, will be the elliptically polarized light. And here the angle, we can see that when the plane of the vibration of the incident plane polarized light makes an angle other than the 45 degree, means the theta is not equivalent to 45 degree, it is other than the 45 degree with the optic axis where a is not equivalent to the b. This is the second case. Now we will move to the last case, that is the third case, circularly polarized light. Here again the angle, the value of the delta will be the pi by 2. Substitute now again the same, cos delta will becomes a 0 as usual and sine delta will becomes a 1. But here both the amplitude a is equivalent to b. The amplitude of the ordinary as well as the extraordinary both are equal. Then substituting these values in the equation number 3 as previous one, we get now x square plus y square is equal to a square. So then this represents the equation of the circle here. The figure has been shown in the third case. This represents the equations of the circle with the delta as an a pi by 2 and the theta will becomes an a 45 degree. It makes an angle of an a 45 degree with the both the amplitude as an a same here. So this represents the equations of the circle with the radius a here. The emergent light will be the circularly polarized one as it is shown in this figure. And it is obtained that when the plane of vibration of the incident plane polarized light makes an angle of a 45 degree with the optic axis and A will be equivalent to the B. So now, till now, we have learnt about this plane elliptically circularly polarized light by the analytical method. So the next class we will go for the another sessions. That is how we will production and the detection of this plane elliptically and circularly polarized light.